For our next example, example 2 from 4.4, note that L'Hopital's rule can be used more than once, which gives us a hint of how we could proceed in this next example. So we have a limit as x goes to infinity of the natural log of 3x plus 5 over the natural log of 7x plus 3 plus 1, with the plus 1 being on the outside of that natural log. So as usual, we try to evaluate this limit directly. As x goes to infinity, 3x plus 5 is also going to go to infinity, so we have like the natural log of infinity, which we can actually refer to our last graph there. It's going to be that end behavior where y is going to infinity. Same thing on the bottom. So we have the infinity over infinity indeterminate form, so we can't tell what this limit is off the bat. But we do know now that we can use L'Hopital's rule, because this is one of the special forms that we can use it. So I'm going to go ahead and take the derivative of the top and bottom, that's what L'Hopital's rule is, and then try to take the limit as x goes to infinity. So the derivative rule for natural log of x is 1 over x. Here we have to also use the chain rule. So I'm going to get 1 over the inner function 3x plus 5, and then I have to remember to multiply by the derivative 3x plus 5, which is 3. Similar thing for the bottom, I get 1 over 7x plus 3 times 7. So as I plug in here, I get 0 over 0, which be careful not to get too crazy with L'Hopital's rule and just keep on doing it, because if you can do some algebra here and determine the limit, then that's something you should do. So definitely we have some things going on here where I would want to take a break here from L'Hopital and at least explore doing some algebra. The reason why is the derivative of 1 over 3dx plus 5, with a 3 on top I guess, is kind of involved. And so, maybe I don't want to just launch into that. So I'm going to do a bit of algebra, which means I'm not going to write the L'Hopital thing, because I'm not doing it. So I'm just going to explore doing some algebra here. And this definitely does simplify. So the 3 and the 7 I'm going to keep in their locations, but then I'm going to write the 3x plus 5 in the denominator and the 7x plus 3 on top. So I'm going to have overall 3 times 7x plus 3 over 7 times the quantity 3x plus 5. So a little bit easier on the eyes for sure. If I try to evaluate this limit in this form, I get infinity over infinity. And the derivative of the top and the bottom is much easier in this one. So this was a better form. Yes, it's still indeterminate, but this is a better form to think about the limit and also proceed with L'Hopital's rule. Now just mentioning an alternative here, that we did have this type of limit before in chapter 2, where we could just use the shortcut theorem or do some algebra here too. But L'Hopital's rule is kind of short and sweet and it's kind of nice, so I'm just going to keep going. And just mentioning here, there's actually a lot of ways to do this limit now from here on out. So I have a constant multiple of 3, derivative of 7x plus 3 is 7. Derivative of the bottom, using the same rules, constant multiple room, but on the 7, 3x plus 5, its derivative is 3, and look at that, I got a constant, and that constant is 1. So the limit as x goes to infinity of that 1 is just 1, so I just found the answer. So note that we use L'Hopital's rule more than once, and that's something you can do.